All right, today we're going to crack open one of the biggest buzzwords in tech, machine learning. We're going to get right down to the nuts and bolts of how a machine actually learns.
I mean, you hear AI and machine learning thrown around all the time, right? But have you ever stopped to wonder what's really happening under the hood? How does a chunk of code go from knowing nothing at all to making these incredibly complex predictions? Well, that's what we're here to find out.
It all starts with something that's actually surprisingly simple and pretty relatable. At its core, most machine learning is really just about solving a prediction problem.
So to make this real, we're going to walk through a classic example together. Our mission, should we choose to accept it, is to teach a computer to do something really specific. Predict how much a person weighs just by knowing how tall they are.
So where does a machine even start? Well, it kind of does what any of us would do when we're faced with a new puzzle. It just takes a guess. A really simple first guess.
Okay, so what you're looking at here is our data. See all those blue dots? Each one is a real person's height and weight. The machine's very first guess is that straight red line. It's trying to find a simple relationship. And that line is defined by that basic formula you see, which is kind of like the model's first super simple theory about how the world works.
The best way to think about W and B is like they're two little control dials on the machine. W is the weight, and that changes the slope, or how steep the line is. B is the bias, and that just moves the whole line up or down. So this entire complicated-sounding process of learning is really just the machine trying to figure out the absolute best settings for these two simple dials. That's it.
Okay, so the machine made its guess, but how does it know if it's a good guess? Well, the next step is absolutely crucial. It has to figure out just how wrong it is. It needs a way to measure its own mistakes.
And this visualizes that idea perfectly. See those vertical lines? Every single one is an error. It's the gap showing just how far off the machine's guess was for that one person. The longer the line, well, the bigger the mistake.
So the machine has one single super important job. It needs to fiddle with its dials W and B to make all those error lines as short as it possibly can. Minimizing that total error, that is the entire game.
Now, in the machine learning world, they have a fancy name for this total mistake. It's called the cost function. But honestly, you can just think of it as a single score, kind of like in a video game, that tells the model how badly it's doing. To learn, the model's whole job is to get that score as close to zero as it can. And that brings us to the coolest part, in my opinion, the actual process of how the machine gets smarter. This is what we call the downhill path to learning.
This is such a great analogy. Just imagine that cost function, that error score, isn't just a number, but it's a 3D landscape like this one. The high peaks and mountains, that's where the model's guesses are terrible and the error is huge. But the deep valleys, that's where the error is tiny. So the machine's goal is simple. Find the absolute lowest point in this entire landscape.
So how does it navigate this landscape? I just love this quote because it makes it all so clear. How do you find the bottom of a valley in the dark? You feel the slope beneath your feet and take a step downhill. That's literally the strategy the algorithm uses.
This whole clever process is called gradient descent, and it's basically a simple repeating loop. First, it figures out the slope right where it's standing. That's the gradient. Second, it takes one small step in the steepest downhill direction. And third, it just does it again, and again, and again, and again, stepping downhill over and over until it can't go any lower. And believe it or not, that's really it. This methodical, step-by-step process of just walking downhill to minimize its own mistakes, that is the very essence of what we call machine learning.
Now, fitting a straight line is a great start, but let's be real, the world is rarely that simple, right? It's full of curves and really complex patterns. So to learn those, the machine needs to go beyond the straight line.
The key trick here is to give our model the ability to bend. And it does this using something called a nonlinear or squash function, like the S-shaped curve you see here. It basically takes the straight line answer and, well, it squashes it, which introduces a bend. This one simple trick is what lets a machine start to learn much, much more complicated relationships in data.
And that brings us to the fundamental building block of almost all modern AI, the artificial neuron. It's exactly what we've been talking about this whole time. A tiny little unit that takes in some data, adjusts it with those W and B dials, and then pushes the result through a squash function to get an output.
Okay, now this is where things get really, really powerful.
One neuron is simple, but as you can see here, we can start connecting them together in layers. By building a neural network out of these simple little units, the whole system can learn to recognize these unbelievably complex patterns. The first layer might learn to see simple edges, the next combines those into shapes, and the next combines those into objects, which is how a network can learn to do everything from spotting a cat in a photo to understanding human language.
So, let's wrap this all up. Let's boil it down. Machine learning is really just about finding a model that fits some data. It all starts with a simple guess, it measures how wrong it is, and then it gets better by trying to minimize that mistake, usually with something like gradient descent. And what's so amazing is that even the most powerful AIs out there are all built on these same simple core ideas.
And that kind of leaves us with a pretty wild thought, doesn't it? If learning is really just this mathematical process of minimizing mistakes, what are the next huge problems we can teach machines to solve just by showing them their errors over and over again? Definitely something to think about.